Hello, this is Yunhan Zhao. I'm very happy to present you our work, GeoFill, reference-based image painting with better geometric understanding. This is a joint work with Connelly, Yuqian, Ali, Sohrab, and Charles. Before we talk about the details of our GeoFill, I want to briefly mention the background. Reference-based image painting aims to fill the whole region of the target image by leveraging another reference image. Compared to single image painting, reference-based image painting is able to handle images with unique background, such as famous landmarks and paintings. In the example below, it is nearly impossible for single image painting to faithfully restore the content in the whole regions. In terms of our contributions, first, compared to the previous work, we propose a more principled approach without heuristic planetary assumption. Second, GeoFill can robustly handle complex 3D scene structure within the whole, wider baseline image pairs, and larger holes. In this slide, we provide an example of our GeoFill. Given a target image, a whole mask, and a reference image, we warp the reference image in a geometrically informed way to provide the guidance for the painting. Specifically, we first estimate initial depths and the relative pose. Then we jointly optimize these two values. We warp the reference image with optimized parameters and post the process with refinement and merging module. We will talk about the details in the following slides. When estimating initial values, we first use a pre-trained model to predict the inverse depths. Meanwhile, we use another pre-trained sparse matching model to predict the relative pose. Finally, we align the depth scale to the scale of the relative pose. In our joint optimization step, we optimize depth scale, offset, and relative pose with following three loss functions. The first and second loss functions measure the difference between target and the reprojected reference image in RGB values and the L2 feature distance, respectively. The last one ensures all projected depth values are all positive. Finally, we reproject the reference image to the target camera position to provide guidance for the whole filling. In the experiment section, we first evaluate the painting performance with different camera baselines by sampling frames with different frame temporal differences. The result is shown in the bottom right chart. As you can see, GeoFill outperforms other state-of-the-art approaches, especially under challenging larger camera baselines. In this slide, we show qualitative results on three different datasets. The top, middle, and bottom rows include examples from user-provided images, RealEstate10K, and the MannequinChallenge datasets, respectively. As you can see, GeoFill has better visual results among all approaches. We also further explored the performance of GeoFill under various hole sizes. As you can see, our GeoFill has better performance for larger holes. Please see paper for quantitative results. We also verify the effectiveness of our joint optimization step by checking the alignment without refinement module. As shown on the right, GeoFill achieves very good initial alignment due to the joint optimization. That's the end of my presentation. Please check our paper for more details. Thanks for watching.